Hi, my name is Ron Chenu, and I'm going to demo a project called Liana, which has the goal of combining the immediacy and user friendliness of projectional editing with the efficiency and fine grained control of traditional text based coding. In the upper left corner, you see these cells. This is the code of the system. At the bottom, you see this grid with boxes with words or icons in them. These are the actions you can perform depending on the context that you're in. Also, each of these boxes corresponds to a key on the center section of your keyboard. So on a standard American keyboard, this corresponds to Q, this box to W, this to E, this to R, and on the next line, this to A, S, D, F, and so forth. So I can either click these boxes here, or I can press, for example, E, S, D, and F. And you may notice in the upper left corner, that's what's moving this cursor right here. I designed this interface to be both discoverable and ergonomic, in that you can access actions with a single key press or open a submenu. For example, this change node action, which corresponds to the J key, opens the submenu right here. So this opens up a wide combination of actions with a few key presses. And eventually, the most common actions that you do will become muscle memory to you. This is my alternative to traditional modifier shortcuts, which can conflict with other programs or might not work on certain international keyboards. And with this system, you don't have to stretch and strain to press multiple keys. This first cell, this pink one, is the label cell. It's the equivalent of a variable name in JavaScript. And I'm going to be comparing it to JavaScript a lot because this is essentially just a light wrapper around JavaScript. The next cell after is the function that will be called. And the result of this function call is the value of this line. So in this case, it's the add function. This is a primitive function. I'll show you how we add those later. And it calls this function with all the cells after. So it's passing 1 and 2 into the add function, and it shows the result here, 3. And that's the value of sum. So let's add a new line. I'm going to click this add line option, and it enters this input mode where I can name this line and give it any name I want. I can put in spaces, I can put in a punctuation, and I'm even going to put in an emoji for fun. I'll press enter to save that. And it defaults to just an empty string. But I can change this empty string right here with the change node option. And I'll go to the op submenu, and this is where all the math operations are. So I'll choose plus, and adding nothing is undefined. But there's two ways you can add new nodes. So I can go to this last placeholder cell and go to change node, and I'll add a number, and I'll enter a new number, and it limits my input to numbers. The other way I can add a node is go to add node, and I'll choose number again, and I'll add 4. And so you'll use add node if you want to say insert a node between 3 and 4. I'll add a 5. And you can see it's updating the result in real time. And as I showed earlier, you can overwrite previous nodes. So I'll change this one to 6. And I'll also try changing this first function here to the times operation. And you can see it changed it to the product. So you can, of course, use previously defined variables. So I'm going to add a new node, and this time I'm going to the choose ref option, and it opens this picker that lists the variables in this scope. Let's see what happens when I choose this same line that we're working on. So I'll choose that, and it gives me this error. You might recognize this is what happens when you get an infinite loop in JavaScript. And eventually this will be more user-friendly. But this just shows one of the ways this system returns errors for you so you can debug them. But let's go back to that picker. And this time, let's choose the sum. And you can see that it inserted it here. And you can confirm that 6 times 5 times 4 times 3 is 360. Now, the first cell after the label doesn't always have to be a function. I can, for example, put in a number here. And in this system, this is like calling the number as a function, which you can't do in JavaScript and seems weird. Now, if you just call the number by itself, it'll just return the value itself, 7, like you expect. However, if I pass in a function after, like minus, this is like calling the number 7 with minus as a parameter. And effectively, the system recognizes this situation and internally swaps the minus and 7. So this allows you to do both prefix and infix notation, which is really nice for operations where order matters, like minus. Now I'll show how to create an array, and it's another operation, which is represented by this icon, and it's just a function that takes its parameters and makes an array out of them. Similarly, to create an object, we use the object operation, which is right here. The object operation just takes a list of key value pairs. Keys are strings, so we'll add that. And we'll make it name. Its name will be Jack. And notice as I'm adding properties, like age, you'll see that it's formatting it for us. So it staggers it, and then it puts it across multiple lines, but puts this connecting thread so you know it's part of the same line. It could have been written the same as the array above, all in one row, but that would have made it very difficult to see which parameters are keys and which are values. With this format, you see this first part is the key, this is the value. On the next line, the first part is the key, the next is the value. And if I add one more line, it'll create another one. Key, value. Now let's try an if statement. The if expression is under the logic submenu right here, and it's another function. It takes 3 parameters, and this missing node error indicates that we need all those 3 parameters before it'll give us a result. So the first parameter is the case to test. I'll just make this true. The next parameter is what to return if that case is true. Let's return 42. And as you can see, it's formatting it again like the object before, just a little different though, and it's adding this label cell just to help make it more readable. And if it's false, we'll return 0. So it is true, so it returns 42 here. And if I change this to false, it returns 0. This is a good time to show how to do nested inline expressions. So we do that by going to this inline action, and it creates this little group here. I'll change this first cell in this group to 1. And I'll add a logic operation. I'll add the less than operation here. And then I'll add 2. So this is a nested expression. 1 is less than 2. Now, remember how we started this line with a number? Well, you can do the same thing with an object, and that's how we accessed object properties. For example, if we wanted Jack's name here, we would make the first cell here that object, and we can choose that right here. And let's rename it to Jack. You can see auto renames right there. Now, if we just call Jack as a function, it just returns itself. However, if we pass in a string, it accesses that property, just like if you wrote jack.name in JavaScript. So if I type in name here, it'll return his name, Jack. Or I can type in an age, and it returns his age, 23. So that's how you do that. So how would we access standard JavaScript functions like math? Well, there's a special operation represented by this globe here, and that's the global object itself. It's a big circular object, so it just says circular here. And as I showed above, if we pass in a string, like math, it'll get the math property off the global, which itself is a big object. Off the math object, I'll get the pow function, which I'll label with caret for the power symbol. So I'll enter this picker, and I'll filter it down with change filter. I'll type in math, press enter to leave that mode, and it filtered it down to that math object for me. So I can choose that, and then I will pass in the string pow, like math.pow, and it returns a function which is represented by this f here. We can use that power function we just created, for example, to figure out 2 to the power of 3. So as I did before, I'm going to start this line with the number 2. And we can pass in any function here. So we're going to choose that caret function we just made. And finally pass in 3. 2 to the power of 3 is 8. So we've seen how to use a standard function, but let's define our own function now. I'm going to go to add function, and it creates a new line, but it also creates this indented line. And we're going to make a Celsius to Fahrenheit converting function. Now we could edit this function out here, but let's enter this live edit mode that popped up instead. This live edit view isolates those function cells and also adds the ability for us to create samples, which are kind of like tests, where the function gets called with each of these samples, and for each call, the execution steps get shown and updated in real time as we edit the function. To create a sample, I go down to this make sample cell where this add sample action pops up. As I choose that, it creates this anonymous line. I can name it. We'll name it A. And we'll make this first cell 20. What this does is it passes in 20 to this function, and it shows the execution order here. Now, that value is not getting used. All this is doing is returning this empty line. So that's all it's doing here. So I didn't explain this earlier, but this first line here is actually different from the lines we've seen before. It's a function declaration line. And eventually there'll be a clearer visual distinguishment, but you can tell because it comes right before this indented line. So when I select this first cell after the label, instead of saying change node down here as you would see for a regular line, it says change name. Because when I do this and enter a name, what it does is it names the first argument for this function. So this line is much like a function header in JavaScript. And now that we've named this argument, we can use it. And the way we do that is we edit this line, we change a node, we choose the ref like before, and in addition to the usual options in this picker, we can also choose the argument that we just named. So when I do that, it inserts that argument as this node. And you can see on the right, when you pass in 20, it returns the argument 20, as we expect. Now I'm going to go ahead and add more samples here. And we'll make this one 40 and this one negative 40. Now we can see the execution stats for all 3 of these function calls in real time and their return result. So let's finish the function. Actually, let me rename this argument to C to make it clearer. And you can see it automatically renamed everything. So first, we had to multiply the Celsius temperature by 9 divided by 5. So 9 divided by 5. Next, I'm going to add a line. I'm going to leave the name blank, and by default, it will just show this left arrow here for the last line to indicate it's a return value. Because by default, the last line gets returned, and eventually you'll be able to change the line order and even choose which line gets returned. But as of now, it just returns the last line. And new lines default to blank, so all these are now just returning blank. And at the moment, names aren't auto-generated, so I'm going to go back to this previous value and just give it the simple name A. So that way I can use it here when you go to the picker and clear the filter and type in A, and we see it down here. It says it's F because A is inside a function and its value depends on the parameters, so we don't know the final value. But we'll choose that. Let me explain in depth what's actually going on. When you call a function with parameters, the first thing that happens is the system looks at the return value, which in this case is the last line here. So you'll see that the return value is A. And now it needs to figure out what A is. And it goes to A and it sees that the first value in that line is C. Well, it figures out that C is 20, the argument that was passed in. And then it knows that this operation is times. And then it has to figure out what 9 divided by 5 is. And so it does that up here, and then that's what gets passed in right here. So code execution is not necessarily top-down like traditional languages. It's actually sort of a lazy evaluation, which has interesting implications, but that's for another talk. So to complete the function, we will add 32. And you confirm these return values with the calculator. These are the correct Fahrenheit values for these Celsius values. So now I'm going to close this edit mode and use this beautiful function that we just made. So I'll create a new line called 100C to F, go into the picker, clear the filter, search for that function we just made, choose it, and pass in 100. And it gives us 212. Now I'm going to quickly run through writing a factorial function, and you'll see how it handles recursion. So that was an example of coding the factorial function using only the keyboard. And you can see that when it hit those infinite loops, it just truncated the first few steps. Let's go back up to the top and look at all these execution cases. Well, actually, let's skip to factorial 2 here, because here we see some interesting recursion going on. And of course, this section is still a work in progress. The formatting and labeling, it will still continue to be improved, but let's see what we can read from this. If you notice, the execution view looks flatter than the original function definition. And that's because since we're showing every step, it puts every inline expression on its own line. And right now, it doesn't really make it clear where it's coming from, but that will be improved. One thing I didn't show here is if I click this to select it, there's this go to def option. And if you click that, it'll take you to the original source definition of that cell right there. So I think it's actually easiest to read this from the bottom up, where we start with the return value and figure out how all the values are derived. So if we run through it, if it's a primitive operation, 0 or 1 gets its value from here, where we see it substitutes in the argument 2. This is a primitive operation, this is a primitive, and that comes out to false. So that's what gets inserted here. And this 1 is primitive. This 2 is the result of an inline expression, which is shown above right here. So this corresponds to this whole line right here. You can see how it's like sort of flattening it out. So if we keep going, we see that this 1 gets its value derived from this line right above it. And here we see the factorial function getting called on 1. So this is where the recursion is actually happening. And you can see right above it, it's showing the execution steps for factorial 1. Like if you notice, it's the exact same as this section up here. So factorial 3 is basically the same thing, just with an extra level of recursion. And I'll leave that as an exercise for you to read through. So there's many more features that I'd like to show and to build, and many more ideas that I'd like to explore within this framework, because I think it opens up the potential for many new programming techniques that will help out both beginner and expert programmers. But I at least hope you got the sense of the general direction I'm heading in. And thanks for your time.